We'll be starting with the saga of number systems with the first session on quantitative aptitude for CAT. Number system is the most interesting topic because you get to know a lot of things about numbers, how they work, and some interesting details like you have never seen till now. For example, if I say that there is a pattern that no perfect square can end with 2, 3, 7, or 8. Did you know that? I hope you knew. But yes, these are things which most of the aspirants do not know actually. And this is a fundamental which can help you in solving a question within 10 seconds. But the first portion that we'll be discussing with you is the whole syllabus of number system and its importance in the various examinations. But here we are focusing mainly on CAT. So if I talk about CAT and that too for the last 3 years, what has been a picture like? In CAT, we have seen number system percentage being 6%, but that is fourth lowest, or actually the fourth highest. But there has been times when number system and geometry used to be going pair in pair. Okay, so we are not very sure that what would be the pattern in CAT 2022 and going forward. But if I talk to you about what happened in CAT 2019, we saw 3 questions from number system. In CAT 2022, sorry 20, we again saw 3 questions coming, but in 2021 there was a surprise in which there was only one question that came from number system, and even in slot 1 and 3 there were one questions, but in slot 2 there was no question at all. So this was a surprise to us, and we are not very sure that what will happen in 2022 because there is different IMs conduct CAT every year. Last year there was one IM. Next year there will be another IM. There is IM, let's say IM Ahmedabad. It's focused very much on probability and permutation and combination. So you have to prepare every topic with total detailing. Okay. So now if I want to discuss with you in number system what actually comes. Number system starts with the fundamental of numbers. Okay, what are numbers? A real number, imaginary numbers, whole numbers, natural numbers, integers. Then we'll talk about prime number, composite numbers. We'll talk about rational number, irrational numbers, and how to convert irrational numbers into fractions, decimals, and multiple details. Okay, so if I talk about numbers, we'll be discussing real and imaginary and the whole bureau of that. Then we'll be discussing odd and even numbers and the logic of odd and even numbers in various levels of examination. We'll be discussing prime number and composite numbers. We'll be discussing perfect square and perfect cubes and the square root and cube roots. This portion in itself forms the most important part of CAT examination, wherein we'll be discussing factorization, factors, multiples, a type of factor which is highest common factor, a type of multiple which is lowest common multiple, and various things about factors as well, like sum of factors, number of factors, product of factors, factors which are not a multiple of let's say 5 but are a multiple of 10, and all these kind of questions that come. We will also be discussing regarding integral solutions, wherein we will be discussing positive integral solutions which are actually natural number. We'll be discussing non-negative integral solutions, that would basically be what? Whole number solutions. And then a very major part again comes remainders, in which we'll be discussing negative remainder, positive remainder, Chinese remainder theorem, negative remainder theorem, formats, Euler's, and multiple theorems. Similarly, we'll be discussing regarding digits, the unit digit, last 2 digits, the cyclicity of the unit digit, and multiple aspects of the same thing. We will also be discussing regarding base system. We discuss mainly about decimal base system, but we'll be discussing regarding how can we convert one base system to the other base system. That would be discussed also with you. We will be discussing regarding factorial, and in factorial, what is the highest power of a particular prime number, of a composite number, or even of 10, which basically means the number of zeros in that. We will be discussing regarding digital sum and how it actually solves a lot lengthy questions in seconds. And at last, we'll be discussing regarding divisibility rules also with you. So that is a complete syllabus regarding number system that we are going to discuss. So let's dig inside and explore the world of numbers. Thank you. So now we'll be discussing regarding numbers. Okay, so the numbers that you are actually aware of are the integers, the decimals, the fractions. But what is the bifurcation of them and where it is used? So the numbers can be real or not real, that is imaginary. Okay, something which is not real, that would be imaginary in nature. But actually, the real number, imaginary number, and there is one more classification which is mostly not discussed, and that is undefined numbers. Okay, the real numbers which do exist in the nature, the imaginary numbers which says that inside the under root there is a number, but that number is negative. Okay, or I can say that a number is not greater than 0, it's actually lesser than 0. If the number is lesser than 0 and we put it in the square root, then that number is called imaginary. Undefined numbers, if a number is something of the form of a upon 0. If something is is of the form of a upon 0, that is considered to be undefined. Yes, guys, it is undefined and not infinite. Okay. Now, what does that mean? Real numbers say I am of the form of p upon q, wherein q is not equals to 0, because p upon q means what? I had q things and I gave you p things out of them. If I have 0 things, then how is it defined to give you n number of things, right? And that is why it is called undefined. Now, real numbers are further bifurcated into two parts, rational numbers and irrational numbers, right? Now, rational numbers and irrational number, what is the bifurcation of that? Again, it is of the form of p upon q, right? And the further classification is fractions. Terminating decimal, the decimals that terminate after some interval of time. Integers, which can be positive, negative, or 0. Mostly that we talk about are positive integers, which are actually natural numbers. And the range goes something like 1, 2, 3, and so on till infinity. Right? 0 and positive numbers put together are called whole numbers, wherein in the natural numbers category, just 0 is also put in, right? And negative number integers are negative integers. So basically, by integer, what do I mean? I mean p upon q form, wherein q is equals to 1. Okay, integers are mostly showcased by a z sign. Natural numbers are showcased by a n sign. Whole numbers are showcased by a w sign. Okay, and negative integers are shown by z minus sign. Okay, at times natural numbers are also shown by z plus sign. What does the sign 0 has? 0 has no sign. Neither it is positive nor negative. Okay. Now, what do we mean by terminating decimals? Terminating decimals are those decimals which terminate after some interval of time. Something like 0.58 is terminating, right? Because it terminated at 8. Now 0.4728954328. It terminated at this point of time, and that's why it is terminating decimal. Now, talking about fractions, they can be of two types. It can be the proper fraction, or they can be even improper fraction. What do we mean by proper fraction? Something which is of the form of p upon q, and q is supposed to be more than p, right? A very proper thing to say. I have 5 things. I can only give you 1, 2, 3, 4, or at the max 5 things, right? So, equal to sign is also there in proper fractions. Now, improper fractions, if it is of the form of p upon q, but q is lesser than p, then that is something which is improper, but still exists in the real world. For example, 7 upon 5. I was supposed to give you 5 lectures, but I gave you 7 lectures. So that would be denoted how? 7 upon 5. Okay. So this is the world of rational numbers. The world of irrational numbers I'll be explaining in the next video for you. If we talk about irrational numbers, so irrational numbers are those numbers which has inside the under root a number which is a non-perfect square. Okay, it is supposed to be a non-perfect square basically. It is supposed to be a non-perfect square. Okay, and the square root of that would be called a irrational number. Okay, basically the bifurcation is of irrational number is it is supposed to be non-terminating, and that is the reason why under root of a non-perfect square is also a irrational number. Because if you just see by doing under root of 5, under root of 41 on calculator, you will see that the numbers are always increasing. They are never terminating itself. Okay, so that is why it is said to be a irrational number. Now, even the special characters, something like pi, Euler's number, and all of them are also considered to be irrational numbers only. Okay, because again, they are also never terminating, and we don't know when does it actually end. Now, the non-terminating decimals are also bifurcated into two parts. One being the recurring decimals, the second being the non-recurring decimal. Recur means repeat itself. Okay, so recurring decimal means if it is repeating itself, something like 0.474747. After this 47, do I know that what would come? Yes, 47 only. That's why it is called recurring decimal, because it is repeating itself. But if we talk about non-recurring decimal, that means which is something which is not terminating, but at the same time there is no fixed pattern as well. 5128 dot 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 dot. After 8, what will come? Nobody knows, right? So that would be a non-terminating, non-recurring decimal. Okay. Now, people say that pi is also denoted by 22 upon 7, but actually 22 upon 7 is a rational number, but pi is an irrational number. Yes, guys. Similarly, even 0.33333 is a irrational number because it is recurring non-terminating decimal. But 1 upon 3 is a rational number. Why? Because it is of the form of P upon Q, and Q is not equals to 0, right? So I have 3 things, I can give you 1 thing. I have 7 things, I can give you, I am supposed to give you 7 lectures, I give you 22 lectures. That is something which is real, which is rational in nature, right? But this is irrational. Okay. In the next part, we will also be discussing how can we actually convert irrational numbers to rational numbers, but wait, you have to wait for that. So, what is the difference between an imaginary number and an irrational number? Imaginary number has inside the under root or the square root, it has a negative number, but it has just a non-perfect square. Okay, this is the major difference between these two. Okay, so this would be all for this particular part. In the next video, we will be discussing how to convert irrational numbers into rational numbers. Thank you, guys. Now we'll be beginning with how to convert an irrational number to a rational number. But before that, we should understand that why do we say that the irrational numbers are illogical and the rational numbers are logical? Because if I take a very simple example like 0.33333 and is so on, it actually means what? That whether you write 0.3 or you write 0.33 or you write 0.333 and so on, they will all mean the same thing. Is it possible? Because 0.3 would be written as 3 upon 10, 0.33 would be written as 33 upon 100, 0.333 would be written as 333 upon 1000. Are they the same thing? Same thing? No. Because if I add 2 zeros here, I'll have to add 2 zeros here. If I'll add 1 zero here, I'll have to add 1 zero here. And if you can see here, this means what? Out of 1000 things, I'm giving you 300 things. This means out of 1000 things, I'm giving you 330 things. And this means out of 1000 things, I'm giving you 333 things. All of them mean different scenarios, right? And that is why it is irrational. Now, if such a question comes, how to convert from recurring decimal to fraction? Let us just discuss. Now, the logic says that this can be written as 0.46, and on 46 we'll have to put a bar. Now, if I multiply 100. As many digits are repeating, 2 digits are repeating, right? So I'll multiply it by 2 zeros, that is 100. So 100x would be how much? It would be 46.464646, which would get repeated itself, right? And what is x? It is 0.464646 and so on. Now, if I actually subtract these two, it would be 100x minus x, that would be 99x. And here it would be 46 minus 0, that would be 46. And all these 464646, all of them would get zeroed down, right? So what the value of x would be 46 upon 99. I will do a couple of questions and then make you understand what is the logic behind that and how you can actually solve it just by seeing it. For example, this is a question. I can actually write it down directly the answer also, but I want to explain to you the concept behind that. Okay, so now this x can be written as 0.532. So 32 is repeating itself, and 5 is one thing which is after the decimal, but it is not repeating itself. Okay, so x can be written as, or actually I will actually write or multiply this by 1000 first. 1000x would mean what? 532.323232 dot dot dot. Okay, and then I'll multiply x by 10. That would be how much? 5.323232 dot dot dot. Now, if I subtract these two, I'll be getting 1000 minus 10. That would be 990 x. And here when I'll be subtracting, I'll be getting 532 minus 5, right? And because 0.3232 are same throughout, they will get cancelled in itself. Now the value of x is nothing but 532 minus 5 upon 990. The last question I'll do, and then I will be discussing with you the trick for that. Okay. Now I'll just first discuss our trick and then I'll solve this question. So the answer to this particular question, wherein x is nothing but 0.78 and only 2 is repeating itself, would be what? Now x would be equal to, in denominator, see here, because 2 digits were repeating, so I wrote 2 lines here. One of them was not repeating, so I wrote a 0 here. So similarly, now only one digit is repeating, so I'll put a 9 here, and two of them are not, after the decimal sign, two of them are not repeating, so I'll write 2 zeros here. Understood? Above part, I'll write 782 minus. Here see, I have to write the whole number after the decimal, which is 532 here, minus that portion which was not repeating itself. So which was that portion? 5 was that here. So here it would be minus 78. So just solve this question by the logic that I have explained and then tell me what is the answer. Are the answers same or not? Okay, I'll be explaining more things, but in the next part of the video. Just try to solve it yourself and then tell me. So now let us try to solve this question using a traditional method so that I can just reconfirm to you that the logic remains the same. Now, what will you do? You will put x to be equal to 0.78. 2 is repeating itself, right? So firstly, I'll multiply it by 1000 so that only after a decimal sign, only those things should be remaining which are repeating itself. So thereby 782 would come outside and only 2222 is there after that. Okay, and then I will put multiplied by 100 also, so that 78 has also come outside, and again only 2222 is remaining there, right? And if I subtract these two, I will be getting 900x, and the value here would be 782 minus 78, because after decimal sign 222, all of them would get subtracted, and thereby the value of x would be 782 minus 78 upon 900. So what is the logic that we were able to find out? Whole number, not the literal whole number, but the complete number, I mean, subtracted by how much? Subtracted by non-terminating part. Okay, the non-terminating part after the decimal sign, divided by some nines and some zeros. How many nines? Those many nines, as many digits are repeating itself. Recurring digits. As many recurring digits are there, those many nines I need to put. How many zeros? Non-recurring digits. As many non-recurring digits are there, those many zeros I have to put. So now, as I have actually formulated the formula also, now I can directly solve it, right? So what would this value be? Now here, 891, 891, 891 are repeating itself. So it is something like x equals to 0.3891 repeating itself. So the whole number, that would be 3891, subtracted by that part which is not repeating, okay, non-repeating, or actually not repeating itself, not recurring term. So what is not recurring here? What was not repeating here? 78. What is not repeating here? Only 3 is not repeating here. Okay, divided by those many nines, as many digits are repeating, so 3 of them are repeating, and 1 0. This would form your answer here. Now if 1 point something comes, then you have to put 1 separate and write 0.42, and now check how many digits are repeating. So if I see here 85488, actually if I can actually cautiously see, I will be able to find out that if not 8 but 5488 and then 5488 is repeating itself. Okay, so 4.428 is not repeating and 548 is repeating. Actually 5488 is repeating. So 4 of them are repeating and 3 of them are not repeating. So 1 I'll put as it is. In the denominator I'll be putting 4 nines because 4 of the digits are repeating itself, and 3 zeros because 3 of them are not repeating itself. And then I'll write the whole number, that would be 4285488 subtracted by that part which is not repeating, which is 428. Just solve it and you will get your answer. I'm not going to solve the question for you. I'm just going to give you the concept here. Similarly here, x would be 1 plus 0.235412. Now only 412 is repeating itself. So my answer would directly be 1 plus, write the whole number, 235412 subtracted by 235, which is not recurring term, upon 3 nines because of 412, which is a repeating term, and 3 zeros because of the non-repeating terms 235. Just solve this and you'll get your answer. That is the logic. Okay, so in the next video we'll be discussing new concepts for you. Thank you guys. So now we'll be discussing regarding a broader overview of a number system with the help of some concepts like unit digit concept, even and odd concept, last 2 digit concept, and the concept of perfect squares. For example, a question something like this come in front of you. Now, do you actually feel you will be solving it like a regular method, which is solve the square of 58, then add it to 14803, solve it from 198 square, then solve 99 square, subtract them, all of them, and then get x square, and then do the square root of that, and then get your answer? Do you think that is a right method to go about it? I am not in favor of that, though I have only taught you Vedic maths to solve such questions with so much of ease. But that method you have to apply when this is a non-MCQ based question, which is an examination of CAT. You will be getting some questions which are non-MCQ in nature. Do for them using the logic that I have taught you. But actually there also you will be having on-screen calculator with you, so they actually expect you to solve using some other logics, which is one of these. How? Let me just show it to you. Now, the first concept is unit digit. and this is actually in the order of the same thing. Unit digit, if I see 8 square, 58 square, if I have to find out, the first thing I have to do is 8 into 8, right? So the unit digit is supposed to be 4 plus the unit digit of 3, that would be unit digit 7. Now x square plus something which is having a unit digit of 7 is equals to what? Again 8 square, it would be 4, subtracted by 9 square, that would be 81. So the unit digit would be 1. So 4 minus 1 would give me unit digit as 3. That means x square is supposed to be unit digit 3 subtracted by a unit digit 7. Now 3 minus 7 is not possible, so I have to take one carry. That means the unit digit would be 13 minus 7. That means ending with a 6. Now if x square is ending with a 6, with what all numbers x can end with? It can either end with 4 or a 6. How do I know that? Just do the square of 4, that would be 16, ending with a 6. Just do the square of 6, that would be 36, again ending with a 6. How many options of them amongst 4 and 6 unit digit are possible? Only one of them is there. So that would become my answer, right? So this is the first logic. The second logic being even and odd logic. Now, x square is nothing but 198 square minus 99 square minus 58 square minus 14803. Now, 198 square would be an even number, minus 99 square would be an odd number, 58 square would again be an even number, minus an odd number. Now, even minus odd, even if you don't remember the formulas, just take an example. Let's say 4 minus 1. What is the even number? 1 is the odd number. So 4 minus 1, 3. That means it would be odd. Even minus odd, again odd. And what would be odd minus odd? It would be even. Just cross check. 7 minus 3, 4, even, right? So that means I am supposed to get x square as an even number. That means x would also be an even number, right? Because when an even number get multiplied by even number, it would be even. When an odd number get multiplied by an odd number, it would be odd. When an even number get multiplied by an odd number, it would be even. Similarly, odd into even would also be even, but in the same thing. The next concept that we discussed here was even plus even was even. Even plus odd was odd. Odd plus odd was even, right? Similarly, minus minus minus. That means even minus even would be even. Even minus odd would be odd. That we saw. Odd minus odd would be even. That also we saw. That means if this is even, how many of them are even? Only one of them is even. So thereby that would be my answer, right? So we discuss unit digit logic. We discuss even and odd digit logic, right? But if in case the option has more than one even numbers, something like this, then what will we do? In that scenario, we will have to use the unit digit logic through which we were able to get it is either ending with a 4 or a 6, right? And amongst these, only one of them is ending with a 4 or a 6. That means only 106 can be the answer, right? This and this would not be the answer. What if I have one more option as 104 also now? Now how will I solve it? Then I will have to apply the logic of last 2 days. That I'll be discussing with you in the next video. Now in the scenarios like this, when you have so many even numbers, 106, 104, 108, now you need to cross check which of them would be your answer, because as per the even and odd logic, you were very sure that the answer would be an even number, right? Thereby you answered 106 here. And then by the unit digit logic, you are very sure that the answer would be ending with either a 4 or a 6. Now we have both the options, 104 also and 106 also, just like we have here, 104 also and 106 also. Amongst them, which one of them would be your answer? The logic says last 2 digits. And what is the logic? Please listen to me very cautiously here. Now, the logic is that 50n plus or minus a square and a square, both of them have the same last two digits. That means the tens and the units place would be the same for all of them. N can be any number starting with 1. A can be any number starting with 1 up till actually 25, or actually I have already taught you the squares till 1 to 31 in Vedic math section. So just go back and see how you can learn the squares of 1 to 31 very soon, and that would be applicable here. For example, if I take a number, let's say a small number, let's say 3. So now 3 square and 50 minus 3 square, 50 plus 3 square. If the value of n is 2, then 100 minus 3 square, 100 plus 3 square, and so on. 150 minus 3, 150 plus 3, 200 minus 3, 200 plus 3. Every one of them will have the same last two digits. So 3 square is 09, and if you solve 47 square, you will be getting, remember how to solve 47 square? Subtracted by 25, that would be 22, and then subtracted by 50 and do the square of that. So 09. See, we have to do this difference from 50, right? So that is 3 only. So 3 square would again be 09 only. That is the logic. Similarly, do it for 53 square also. Now, after subtracting it by 25, that would be 28. But again, I have to subtract it by 50 only, right? So again, 53 minus 50 would be 3 only. So 3 square would be 09. Similarly, 97 square, same logic. 97 square subtracted by 3, that would be 94. Take the square of 3, that would be 09. 9 for 09. 103 square added by 3, 106. Do the square of 3, 09. All of them are ending with 09. And that is the logic which you can use here. Because if the 58 square, now what can I say about it? I can say that 50 plus 8 square and 8 square will have the same last two digits. That means this would be 64, right? This is anyways 03 only. So on the with x square, I am getting what? X square plus ending with a 67. Here 198 square, that would be 50 into 4, 200 minus 2 square and 2 square will be having the same last two digits. That means this is going to be 04. Similarly, 99 square, that would be 100 minus 1 square and 1 square would be having the same last two digits. That would be 01. I have to do the subtraction of that. So that means that would be 03 ending with a 03. Now x square would be ending with a 03 subtracted by ending with a 67. What you will be getting? 103 minus 67, that would be 6 and 3 here. So it is ending with a 36. Amongst 106 square and 104 square, which of them is ending with a 36? Just cross check. 106 would square and 6 square would have the same last two digits, 36. 104 square and 4 square would be having the same last two digits, that would be 16. Is my answer 36 or 16? 36. So that's why 104 cannot be my answer. And that is the logic I wanted to discuss here. Okay. So in the next video, we will be discussing regarding perfect squares. Thank you guys. Now we will be discussing regarding perfect squares, and with the help of which we will be solving some questions like these in a much better and a faster way. How? Let me just discuss. Now, no perfect square can end with 2, 3, 7 or 8. 10n plus x or minus x square will have the same unit digit as x square. For example, I have taken the number as 4. Now 4 square unit digit is 16, actually 6 only. And if I say 10 minus 4 square, it would be 6 square. So its unit digit would also be 6. Similarly, if I would take 10 plus 4 square, that would be 14 square, that would be 196. Again, the unit digit would still be 6. And not just for n's value to be 1, You can take n value any number you want. Let me take n value to be 9, let's say. That would be 90 plus 4, 94. If you take the square of 94 square, you will be getting the same answer, right? So what is 94 square? It would be minus 6, because with respect to 94, with respect to 100, 94 is 6 less. So do 6 more less and do 6 square, that would be 36. Now these concepts again I have discussed in Vedic maths in the Sutra number 1, Ekadikena Purvena. So just go back and see there what did we discuss at that point of time. Yeah, so the unit digit is still 6, and that is a logic. Similarly, if we talk about 50n plus or minus x, 50n plus x or 50n minus x square will have the same last two digits as x square. For example, if I have taken the value of x to be 7, so 7 square is going to be 49. The last two digits are 4 and 9, 49. Now, if I take n's value to be 1 simply, or n's value to be 2, let's say, in that scenario, it would be 100 plus 7, 107, and 100 minus 7, that would be 93. So both of them would have the same last two digits, okay? And what was the logic? It would be plus 7 with respect to 100, so that would be 114, take the square of 7, that would be 49. I am doing it little fast because I expect you to have seen the Vedic math session and then come here, okay? Similarly, minus 7 here, whatever it would be, 7 square at the end is going to be the essence which I was supposed to discuss here, right? So these things are, I guess, are very clear to you. The next concept that I needed to discuss right here was that any number ending with a 1 or a 9, its square will always end with 1 only. Okay, 11 square 121 ending with a 1. Similarly, 9 square is 81, 19 square is 361 ending with a 1, right? And even before that it would be an even number. Okay, 1, and before that there will be an even number. For example, 11 square, that is 121, so 12 is an even number. Similarly, 2 or 8 square will end with a even 4, right? 12 square 144, 14 is even and ending with a 4. 18 square is 324, 32 is an even number ending with a 4. Any number ending with 3 or 7, its square will be ending with a 9. For example, 13 square 169, 16 is even and ending with a 9. 17 square, okay, 289, 28 is even and ending with a 9. Similarly, 4 oblique 6, okay, I had to write even here. It ends with a odd 6, guys, odd 6. 14 square is 196, 19 is odd, ending with a 6, okay. 16 square 256, 25 is odd, ending with a 6. So these are the concepts, right? Any number ending with 5, its square will end with 25. So obviously it would also be an even number, because just before the unit digit it is a there's 2. And what is the definition of an even number? It is of the form of 2n. And what is the definition of an odd number? It is of the form of 2n minus 1. Why we take odd number to be 2n minus 1 and not 2n plus 1? Because n's values start with 1, right? So if I'll put n 2n plus 1, then n's value 1 would take me to 3, not 1. And that is why we have to do that, okay? So these are some of the concepts you need to know regarding perfect squares. Using that particular logic, you need to solve this question with these options, and even when all of them are ending with a 6, that too. That I'll be discussing with you in the next video. Thank you. So now let's start and try to solve this particular question with the help of the logic of perfect squares that we have just learned. Okay, these were the concepts and these were the concepts that you just learned, right? Now, you can see here also, is it ending with a 1? Yes, it can. Is there any number which is ending with a 2? No. Is there any number which is ending with a 3? No. 4 it is ending? Yes. 5 it is ending? Yes. 6 it is ending? Yes. Is it ending with a 7? No. Is it ending with a 8? No. It is ending with a 9? Yes. Ending with a 0? Yes. Any number ending with 0, its square will end with 2 zeros. Okay. So from 0 to 9, from anything it can end, but not with 2, 3, 7 or 8. And that was the concept that I wrote as a first point of reference for you. Okay. So Now try to solve this particular question. I hope you have solved it, and to avoid the repetition of the same concepts again and again, I have taken the screenshot of what we have done till now already. So x value, x plus something ending with a 7 is equals to something ending with a 3. This we have discussed earlier also. So x would be equal to something ending with a 3 minus something ending with a 7. And that would be equal to ending with a 6. Now, can it be a even 6 as per the logic that we've discussed earlier? I don't think so, right? Why? Because it can never end with a even 6. So thereby this cannot be the answer. And only this option can be the answer because it is ending with a 6. So this and this cannot be the answer amongst A and D because this one is having a even 6 and this one is having a odd 6. So thereby the odd 6 one would be the only answer. Okay. But if the option would have had E option to be 11216 or 96, something like that, then again this cannot be the answer. That we will be able to find out with the help of the last two digits logic. Okay, so this is something we have already done, so I'll not be discussing at length here. But in case such options come in which there are last digit or logic will also not work for you, then you have to go by the basic methodology. And what is the basic methodology? With the help of Vedic maths, solve 58 square. That would be how much? It would be 50, the difference with 25 and the difference with 50 you have to take. Right? Remember the logic that I taught you for finding the square of any number between 25 to 80, right? So what was the logic? Subtracted by 25, write it here, subtracted by 50 and take the square of that. So 58 minus 50 would be 8 and 8 square would be 64. Add this to 14803, right? 7, 6, 11, 8 and 1. So x plus this much is equals to 198 square. How will I do that? Now it is 2 into 100, right? It is 2 into 100, the base value for 198. And how much is 198 away from 200? It is 2 away. So I write 196 here. And for the last two digits, because the base has two zeros, I'll do the square of 2. But 19604 would not be my answer. I have to multiply this by 2 as well, because whatever you do to the base, you have to do to the number as well. Okay, so that would be how much? Now 200 into 2 is 400, but it is 4 lesser. 196 is 4 lesser. So 4 plus 4, 8 lesser. So it would be 400 minus 8, that would be 392. So 39204, or you can simply multiply also, would be the answer here. And what would be 99 square? Using the same logic, the base value is 100. So minus 1 would make it 98. And for the last two digits, I have to do the square of 1. So that would be 01. I have to subtract this number by 9801. Okay. So this would be 3, 0. This would be 4. Anyhow, 38 minus 9 would be how much? 38 minus 10 would be 38 minus 10 would be 28, but it is supposed to be 1 more than that. So that would be 29. Okay. So 29403 would be coming on the right side of it. So 29403 here. So my x value would be 29403 to be subtracted by 18167. I'll just subtract it. I'll be getting a 6 here. Okay. Then I'll be getting 10 minus 6. Sorry, actually 9 minus 6. That would be 3 here. And then it would be 112. So 11236 would be a subtraction of it. And which amongst them is that answer? It is 11236, right? 11236 would be our answer for this particular question using Vedic maths now. So depending on the options, you have to choose your answers. Okay, so we have done the logic of perfect squares, and now we will be doing the logic of percentage in the next video. Thank you guys.